Types of satellites here. Usually satellite refers to so first if we refer satellite, what is a satellite means here? It refers to a machine. So this, if you see, it is like a machine which is launched to it is launched to a space here and moves around the earth or any another body in space. So any another body in the space. So this satellite is helpful to, it is like a torchlight to see every area very clearly. So to see our earth or otherwise to see any other planet outside our earth. And a satellite is an artificial object here. It is not a natural one. Why? Because it is prepared by man, a man-made object. So that it is an artificial object, and which is intentionally placed on the orbit of the earth. So if this is the orbit here, we said already orbit, it is called as a path. So intentionally it is kept there and to visualize our earth, and such objects are sometimes called as artificial satellites here. To distinguish between natural and artificial, it is that earth's moon and sun's earth. That means here some of the objects are sometimes called as artificial satellites. To distinguish it is different from natural satellites here. So what is that here? That means here earth's moon or otherwise sun's earth. And usually why do we need satellites here? So usually why do we need satellites means here satellites allows us to see larger areas first. So here one satellite, it is managing to see many larger areas which are there on the earth at a time. At a time, if you see all the areas, it has been made here. Even in every area, isolated area, rural area or urban area, it has been made. And the ability means satellites can collect more data and more faster than instruments on the ground. That means on the earth, whatever instruments are there to calculate. So here it will collect a maximum data by this satellite here. And the reason being that satellites fly above the clouds and the dust and molecules in the atmosphere, and also it can also which cannot block the passage. That means here if a car is moving here due to dust or otherwise bad weather, it cannot cover other area. But for satellite here, these barriers are not like a barriers. It can cover a large area and larger information in a fraction of seconds. So if you just see about the parts of a satellite here, you can see all satellites will have at least two parts. First one, it is antenna, and again next one, it is a power source. So and that means here the antenna will sends and again receives the information and more quickly to the earth. Understood? And the power source can be used here either like in a solar panel or the battery here. So most of the satellites will use solar panel. Here if you see a command antenna is there and communication antenna is there in case of antennal parts here, and in case of power, solar cells are there, batteries are there here, and inside if you see radio TX RX is there, and fuel will be there, motor, thrusters, camera. These are the parts of the satellites. Camera, with the camera, it can take maximum hundreds, more than hundreds to thousands of photos will be taken of the space, and it will send into the earth usually. And antennas also, downlink antennas will be there, command control antennas will be there here. And this is about the satellite structure, complete satellite structure here. And the next one here, many satellites will carry if you see camera and also some scientific sensors will be there here. Scientific sensors will be there here. We cannot see as it is a basic diagram, and sometimes these instruments point towards earth to gather information about its land, air and water, and other times they face towards the space only to collect the data of solar system or the universe here. If it is facing towards the earth, then land, air, water details will be there, and if it is facing towards the space, then it can cover the solar system or the universe. Next one here, if we think how this satellites will rotate around the earth or how the process will start, we'll just see here. If you see in the satellite here, it is rotating around the earth. This is one representational image only, so it will collect around the earth and again collect the larger information within fraction of seconds and on the time bound. And usually these satellites will orbit the earth with speed balanced with the pull of gravity only. Due to attraction of gravity of the earth, then this pull will be made and it will rotate around the orbit of the earth or wherever it is placed on the space. And then without this balance, the satellite would fly uh, in the straight line of or into the space, or fall back to the earth. Sometimes here what will happen here, the speed of the satellite is not matched with the speed or rotation of the earth here, so sometimes it fall here or sometimes it go away from the earth here. Like here if you see, this satellite is exactly balanced with the speed of rotation of the earth and again the rotation of the satellite. They are equal so that it is linked easily in the orbit and again it can rotate around the earth. Otherwise it may fall here or it may fall to the outer space like this. And again without this balance, the satellite would fly in a straight line off, or otherwise it can just go to the space here. If it falls in the sometimes instances are there where satellites fallen on the earth also. Maximum they launch near to the water bodies here, and near the water bodies only they launch, so they go, and if they fail it will fall in the water bodies only. And satellites orbit earth at different heights. So as we discussed here, eccentric orbit, low earth orbit, geostationary orbit, polar orbit, so different heights, different speeds, and along with the different paths also it will move. And the common types of nearly geostationary and polar are the common types usually in this. And if we discuss that, a geostationary satellite travels from west to east. This you need to remember. Geostationary satellite, I'm rubbing here, geostationary satellite travels from west to east. This you need to remember. Geostationary satellite, it will just travels from west to east over the equator. Understood? Over the equator it will make from west to east. This is important. And from earth, a geostationary satellite looks like a standing still. Since it is always in the same location. Stationary means here station, fixed, you need to remember that. And polar orbiting satellites here travel in a north and south direction. You know very well that about that. That means north and south direction it will cover all the times. It will cover north and south direction, and these will cover entire globe one strip at a time. That means it will scan entire globe in a strip while moving. And after that we will discuss about types of satellites here. How many types of satellites are there here? So satellites usually can be classified by their function, since they are launched into space to do their job. And for example, satellite that is launched to monitor cloud patterns for weather. That means cloud patterns for weather station. There will be different satellite launched to send TV signals. So weather is different, TV is different. And now we discuss some of that. Here you are seeing, what you are seeing here, the picture is about communication satellite here. So what is a communication satellite here? This will allow the radio, television, and telephone transmissions here, what we are talking now, to send live anywhere in the world very faster. These are very faster here. And the purpose of this communication satellites is to make signal around the curve of the earth here. Around the curve of the earth, signaling will be there here, and it will allow all the communication between widely spread points from one point to another point. Very fastly the communication will be made. And communication satellites will use which waves here. This you need to remember that the waves are most important here. They use microwaves and radio waves for transmitting the signals here. Communication satellites, you need to remember microwaves and radio waves. They will use for this communication purposes. Before communication satellites, transmissions were difficult or impossible at longer distances, and the signals which travel in straight lines usually at long and could not bend around the Earth. So to reach a destination far away, now communication satellites are in the orbit. These will be in the orbit, and signals will be sent instantly to the space here, and then directed onto another satellite here, and directly to the destination here. There are two types of communication satellites are there here. One is passive. Let me rub this one. Two types of satellites, this communication satellites are there. First one it is passive, next one it is active. So passive satellites here, they will bounce the signals from the earth and back to the location on the earth, whereas active, they will carry electronic devices like transponders. They're called as transponders for receiving, and for amplifying. That means these are very faster, usually amplifying and rebroadcasting signals to the earth here. So these are very actively participating one. So passive means just rebounces it here to information, but here these devices will called as transponders. In UPSC questions will be there, transponders are used in which type of communication satellites here? Active communication satellites here, and again it will receive and it will amplify, it will increase the signal, and then it rebroadcast to the earth here. And communication satellites, if we discuss in India, how many are there means here two series are there usually. INSAT series here, INSAT series and GSAT series are there. Two types of communication satellites are there. So INSAT, Indian national satellites here, Indian national satellites here. So navigation, next type is navigation satellites. So if you see this picture, you can understand navigation means here it is making a mapping, for mapping and addressing and the traveling purposes. Navigation satellites are useful. So a system of satellites that provide autonomous and geospatial position with the global coverage. So these all will cover very widely with the global coverage here of a moving object. If a moving object is there on the earth here, with every accurate point it will make the geospatial position with a global coverage, designed expressly to aid navigation of the sea, air with the radio waves. Here radio waves are most important here, understood. And the next one, this will allow electronic receivers to determine their location to high precision. Very high precision will be their location will be given very high precision, and how they will be given, it will be given by signals here, and along with the line of the sight called as a radio waves through the satellites here. So through the satellites here, what will happen, radio waves will be sent, and then it will make accurate one. And next one, if you remember, it will also allow electronic small electronic receivers here to determine their location and having very high precision thing. And this navigation system with a global coverage may be termed as a global navigation system, satellite system, GNSS. This system is otherwise called as global navigation satellite system. Currently global GPS system is running, and Russia's GLONASS is running here. So GPS is running, and again GLONASS. In the future we can see India's also, it is called as NAVIC. Next one here in this only, China is also in the process of expanding this one. It's a regional navigation system called as vIjAyS navigation satellite here. The name itself you can say the word has formed from China. And next one, this will make like a compass navigation system, and this will release by this year or next year, 2020 or 2021. And the European one also is there here, Galileo. It is called as Galileo. Galileo is here, you are seeing about Galileo picture only, and this also will be developed by this year or otherwise by 2021. And Japan also making one navigation system here, 𝐾𝐲𝐚𝐻. This you need to remember, 𝐾𝐲𝐚𝐻. Why I am not making typed text means here, typed text means you will forward and you will make like this, means you will listen continuously without any disturbance here. Japan, so you need to remember, that means here. And GPS is Americans here, sometimes we can call a GPS, and again China's you can know vIjAyS navigation system, and Europeans Galileo, and Japan's it is 𝐾𝐲𝐚𝐻, and India's it is NAVIC. and to say that some more topics are there with respect to India's here. It also has a augmentation system here, which is otherwise called as 𝐺AGN. So what is 𝐺AGN here? GPS aided geo-augmented navigation 𝐺AGN. This will enhance very accurately and also with NavStar GPS. NavStar GPS. This system will increase this system, and again GLONASS positions also. And India is also developing one of the very fastest one. It is called as Indian Regional Navigation System Satellite, IRNSS. Next, remote sensing satellites are there here. So remote sensing satellite means here these are observed and measured our environment. Usually environment will be observed, that means how sun's rays are falling and how clouds are there and how weather forecasting will be there on the earth continuously. It will be used from a larger distance, that means earth observatory satellites are there here on our earth. So they will continuously like this, they will be continuously focusing on the earth, what is happening. Satellites are like camera, whatever happening there it will collect that and it will send it to our earth. And here it is used as a in the sense of electromagnetic radiation. Here EMR is normally used for the information carrier, sometimes radio waves like that it is there, but here in remote sensing satellites you can see it is used with the electromagnetic radiation, and the output of the remote sensing satellite is usually an image representing a scene being observed there. So electromagnetic radiation will be making and a scene is created there, then it will be made. And after that what will happen, the data from these satellites are used for several applications like agriculture covering, water resources, urban planning and rural development, mineral prospecting and environment, forestry and ocean resources, whatever resources are there in oceans, and disaster management. And how many remote sensing satellites are there in India? If we look over that, so there are nearly 4 are the remote sensing satellites. One is IRS, that means Indian Remote Sensing Satellite Series, and Cartosat is there, Cartosat. And next one OceanSat, Resat, that means Resorts Satellite. Next Bhaskara satellites. After that Mega Tropic satellites. After that satellite with Argos and Altica. So once again, what is this here? Remote sensing satellites are IRS satellite, Resat, Cartosat, OceanSat, Bhaskara satellites, Mega Tropics satellite with Argos and Altica. Next one, it is about space exploration satellite here, and this is will be the last one. Space exploration satellites are not really satellites at all, but they are properly known as the space probes. They are otherwise called as space probes. Space probes means that they will send back detailed pictures and atmospheric data of planets and other stellar phenomena. That means whatever stars information is there, whatever planet information is there, they will take the pictures and they will send back to the earth here. And space exploration satellites must be built to last, because it takes so long for the satellites to reach their destinations. Why? Because space it is going to explore, so it takes a very larger distances to cover, and there's a technology also, it involves a very hard also, and satellite financially also it can be taking huge amounts. And next to this space exploration satellites will be must be built to last to reach the destinations. High cost is maintained here to explore the space. And how many space satellites so far are there in India? In India nearly 3 are there. That means here SROS means here Stretched Rohini Satellite Series, and Chandrayaan 1 is there, and Mars Orbiter mission is there, Mangalyaan.